The second property that we learned for simplifying monomials is called the properties of powers. And it usually is of the form, like over here, am parenthesis to another power n. So if we do this example I have over here with x in it, we've got x squared raised to the fourth power. So again, exponents are like copies, and so I could think about this as, oh, I've got x squared copied 4 times. So there's one of them, and each copy is multiplied to itself, or by the others. I've got 4 copies of whatever x squared is. I say, okay, well, if I think about the other property that we use, the product of powers one, then I know that when I've got a common base like that of x, I can just add the power, the exponent of each of them, and rewrite it as x to that new power to more simply write it. So 2 plus 2 plus 2 plus 2, well, that's x to the 2, 4, 6, 8. Well, that was a lot of work if I know the shorter way of just saying, following this property and saying, hey, 8 copies, well, that's the same as if I had just taken my original power of 2 and multiplied it to that parenthesis power of 4. So if I said x2, the 2 times 4. Well, 2 times 4 is 8, and I get the same answer, but I did it in 2 lines less, 2 lines fewer. So that's the cool thing about the property of powers, is whenever you have a value raised to another power, like x squared raised to a power of 4, then you multiply the exponents. We're multiplying instead of adding the exponents like we did with the other property. So multiplying versus when I had a common base times another common base, like over here with the product of powers property, we were adding the exponents, and that's why we added up here. So slight difference and yet huge difference. So let's do an example. Let's say we have 3u to the power of 3. Alright, so the first thing with this one is I see I've got the variable u in there, but I also have a coefficient other than 1. I've got a 3 in there. And the way I like to remember how to use this property and to not miss anything is I put in those invisible exponents if they're not there. There's a 1 on my 3 because I have 1 copy of 3, and there's a 1 on my u. I have 1 copy of u. And then if we use the new property that we just used, it tells me that I need to multiply the outside exponent of 3 into each of the exponents of the values inside. So of the coefficient 3 and of the variable u. So if we do that, we get 3 to the power 3, because 1 times 3 is 3, and u to the power 3. And I can multiply out 3 copies of 3, because I know what 3 is. I can actually write the value of that without a power. So 3 times 3 is 9, times another 3 would be 27. So the most simplified way to write this would be 27u cubed. Now let's check it if we did it the other way. If I wrote out 3 copies of u, or 3 copies of 3u, and multiplied them together, would we get the same thing? Well, I'd end up with 3 times 3 times 3, that would give me 27, and I'd also end up with a u, and another u, and another u, so that would give me u to the 1 plus 1 plus 1, oops, because whenever you have a common base, like u and u, we add the power, add the exponents. So I get the same answer, 27 from 3 times 3 times 3, and u cubed. But it was a lot faster to use our new property.